Can you guys hear me? Thank you, Adam. I'm Ajay Nupane. I'm currently a postdoc at the University of California, Riverside. This work was done when I was a PhD student with Dr. Saxena at University of Alabama, Birmingham, with Dr. Hospill and and Sarah from Syracuse University. Let's get started. Which one? This is the one. Okay. So we leave our voice traces behind us, right? What's the aftermath of it? How difficult is it to make a machine talk like you? Currently, there are lots of voice morphing technology like Lyrebird, Fastvox that can generate spoofed voices of people. Voices are a unique identifier. It's used in voice-based user authentication system. And currently, there are scams that are running based on these morphed voices. For example, like grandparent scam. In grandparent scam, what they do, they pretend to be a grandchild of someone. They call the old people and they say that, oh yeah, we are in trouble, can you please send us some money? And the parents think that, oh yeah, it's actually my grandchild, and they send money to them. This kind of scams are running. In this study, we're trying to understand why users fall or why users are vulnerable to the voice morphing attacks or fooling attacks. The previous studies have shown that human-to-human based speaker verification systems are vulnerable to voice morphing attacks. There were studies in CCS and Izorix. In this study, we're looking at the fundamental component, the human brain that governs the decision making in human, and trying to see what happens in human brain when they are subjected to this kind of attacks. Previous studies were done on a similar premise. We conducted a study with the phishing websites. We're trying to identify what happens when users are subjected to a real website and a fake website. We saw that users were not doing that good, but when you look into the neural signals, there were differences when they were seeing a fake website and a real website. And if you build a machine learning model just trained on the neural cues, for the users that were performing below average, the machine learning model just based on neural cues gave better results. And there was a study on neuroscience based on the Rembrandt paintings. They saw real and fake Rembrandt paintings, and they identified that there were neural differences, even though users were not able to identify it. So we hypothesized that in voice morphing attacks, even though users might be falling for this kind of attacks, there might be some differences in neural activations in the decision-making areas like frontopolar and temporal parietal areas when they are listening to the morphed voices. These are some of the areas we found in our previous studies, and we design our task to study or to test this hypothesis. So the task we performed was a speaker legitimacy detection task, which we define as a task in which a participant has to identify if a given voice is real or a fake voice. We don't tell, before saying that, like we used two types of speakers, two familiar speakers, the speakers which the participants already knew or they were familiar with, and two briefly familiar speakers. We picked participants from, or users from Mechanical Turk to generate briefly familiar voices. And we generated two types of fake voices. One was the morphed voice generated from machine. Next was a different speaker voice. It was just like a speaker trying to speak in your tone or your style. So what we did, in our study, we played a sound of a original speaker for 60 seconds. And we played different samples randomly to the participants and asked them, can you identify if the given voice is real or a fake? The voice samples were played for 15 seconds, and we gave them a rest of 8 seconds in between in rest. And we asked them not to move and just clear their mind and stuff. To measure the neural signals, we used fNIRS. fNIRS is a non-invasive technique. It's a very lightweight headset that covers the area you want to measure. It actually works on the Bold principle, which means the area that is highly activated that consumes lots of oxygen. So you can measure based on the infrared rays that goes inside the brain. The absorption of oxyhemoglobin and deoxyhemoglobin is different, so you can figure out the activities inside the brain, and you can localize which specific trial what activity is related to, and you can analyze that afterwards. It is said to have better resolution than EEG, better spatial resolution than EEG, so you can look at greater area, and it has got a higher temporal resolution, so you can see how fast these areas are being activated. We displayed stimuli in a laptop separately from the machine that was recording the brain signals. That's how the setup looks like. For data collection, our study was approved by IRB. We followed all the standard procedures that has to be followed to protect the privacy of the users. We recruited 20 healthy participants from mostly from the university community. They were like staffs, students from the university community. All were English-speaking participants. We tried to balance the users, like we had 10 male and 10 female participants. Most of them, like the user range was 19 to 36 years in age. We removed the high-frequency noises from the brain data, like your hand movement. Like even though we asked users not to move that much, they keep on moving, so we had to remove these noises. We used bandpass filters for that. We removed the artifacts, and we averaged, so the sampling rate was around 10 hertz, so we averaged the neural signals for each trial, and we compared the neural activities when the activations were in the brain, when people were listening to real, morphed, or different speakers' voices. This is what we did for the analysis. We looked at the 5 specific areas in brain that we found to be activated in our previous studies. The first 3, dorsolateral prefrontal cortex, orbitofrontal, and gyrus and frontopolar area are the areas in the front part of your brain that are related to the decision making and the executive functions like take a right turn, take a left turn, time management and stuff. So that's related to decision making. The other 2, superior temporal gyrus and middle temporal gyrus, they are the parietal areas on the side of your brain. Previous studies have found that they are activated when people are looking at the known faces or when people are listening to the famous speakers' voices they already know. So we thought like we should see some activities or difference in activities in these specific 5 areas. We performed the following statistical test. Our data was mostly non-uniform. So we used Friedman test and Wilcoxon sign rank test to measure the differences. And since we were doing multiple comparisons, real fake, real morphed, real different, so we applied Bonferin correction for the multiple comparisons. Just wanted to highlight the functions of the brain areas that I'll be talking forward in the next slides. So these are the specific functions. Most of them, they are related to memory recall or working memory in the brain. And the orbitofrontal area is slightly interesting because this area, like the previous studies, I found that this area is activated if people distrust something. So we were hoping we'll see some activations specifically in these areas when people are listening to morphed voices. So let's see, first thing, we asked participants to identify the fake voices. Are they even trying, right? So we wanted to see that. For that, we compared the activations people who are listening to these voices with the rest when they are not doing anything. We saw the activations specifically in the decision-making areas. So they were doing good with they were trying the original, trying to identify the original voices, morphed voices. Similarly, in the different voices as well. In morphed voices, you see that there's no activation in the orbitofrontal area. But in different voices, if you look at it, there's some activation in the orbitofrontal area. This is just in comparison with the rest, but still we see some activities in the orbitofrontal, which means they might be having a doubt on the different speaker's voice, but maybe not in the morphed speaker's voice. Let's look into more details. So we compared original and the morphed voice samples, brain signals, because that's what we were interested in. We did not observe any statistically significant differences in the 5 areas we considered for the analysis. We did this for both gender types, male and female, still no differences among the genders as well. One of the interpretations is that the voices that were generated that were very close to the original voices, and now, like the human brain, it couldn't differentiate. There were no differences in the activities at all. Even though no significant difference may not mean, oh, there are no differences at all, but our study cast a serious doubt that the humans might be biologically incapable to identify this kind of voices naturally. One more thing, in our study, we didn't say to the participants that the samples that we are presenting to them might contain morphed voices. We just said them that there are fake voices. They didn't know the fake voices might come from a different speaker or from a morphed speaker. Since they didn't know, they couldn't guess as well, maybe. That's what we assumed. But when you look at the original and different speaker's voice, we saw the differences in superior temporal gyrus. The superior temporal gyrus, a study in neuroscience, there are a few studies in neuroscience which found that these areas are activated when you listen to a speaker that is familiar to you. Original speaker, were familiarized to the participants, so they knew like, okay, this is the speaker, so they had the activation in this area, but different speaker, they could easily recognize, oh, this is a different voice, so they might not have activation in this area. That wasn't the case in the morphed voice samples. We saw similar observation for genders, and we did not see any differences in other areas of the brain as such. Let's look at the task performance. The brain results justify, like the task performance justify the brain results as well. We can see that overall they were able to identify the fake voices on average by 64% only. And the participants reported that 58% of the morphed voices were real speakers. While they were doing a little bit better in different speakers' voices, they had got like 33%. The only 33% of the time they said that different speakers were real speakers. We tried using machine learning on the brain data as well to see if we can capture, if the machine learning can capture some differences. We extracted the features, and we used off-the-shelf machine learning algorithms to model it. We didn't see any good results as such. The best F measure we could achieve was of just around 53%. So looking at the statistical analysis on the brain data, the machine learning on the brain data, we didn't see any differences when users were listening to the original voices and the morphed voices. So the first thing is that the study shows that the human might be inherently incapable to distinguish this kind of morphed voices. So maybe the users should be trained properly. There should be a specific training on this kind of voice samples, because the scams are now currently running as well. And the morphing technology we used was from CMU FaceBox. Right now there's Lyrebird, which creates even better samples than what we used. So the samples are increasing every day, right? So this kind of attacks might be more serious in future. We might have to develop better technical solutions to assist users. I saw previous studies, like there are these adversarial samples fooling machines as well. So we should do better on that, it seems. And the positive side of our study is that the voice morphing technology may be mature enough to serve those who have lost their voices, because there are no differences in the morphed voices and the original voices when humans process it. We had some limitations of our study. It's a lab environment, so the participants might have performed slightly different. And we had played a repeated sample, so they might have some trouble in identifying the samples correctly. Many of the participants were young, so if you consider old participants who has got some hearing disability, it might even be worse than that. And the device we used was fNIRS, which has its own limitations. It can't measure the deep neural areas, so there might be some differences in the deeper areas if you use other devices. To conclude, we try to study why users fall for voice morphing attacks, applying neuroscience and neuroimaging principles. In our study, we did not observe any significant differences when users were subjected to these voices. They had relatively low behavioral performance, and we conclude that the users may be biologically susceptible to morphing attacks, and only proper training may help them. Having said that, I conclude my talk. I'm happy to take any questions. Thank you.
So if we have any questions, feel free to queue up. While you're thinking about that, I definitely have a couple. So one thing that, as a layman in this space, as I think many of us are, I'm wondering if, with these celebrity voices, like a Morgan Freeman or an Oprah, their voices are so distinctive that if you attempted to create a synthetic version of those, they're going to look more like the authentic thing than anything else the speaker's ever been exposed to. Did you look at the differences between the celebrities and non-celebrity voices in terms of people's classification?
We did it.
Yeah.
And you are right. People are doing better in the famous voices. And even if you look at the neural signals, the famous speaker voices, they had got better activations than the briefly familiar voices. Like those people with whom the participants were not that familiar with, they didn't perform better on those things.
Okay.
That's definitely true.
Nice. So that might suggest a silver lining here in terms of maybe unless you're impersonating a celebrity, there's still an opportunity for humans to differentiate.
Yeah.
Okay, nice. Question?
Hi, Louis from UF. Great talk, by the way. Quick question. At the very end, you said some training might be required to get people to differentiate. Can you comment to what type of training that might look like, or what might that look like?
So as I said before, in our study, we didn't tell participants that these voice samples contain morphed voices, right? Mm-hmm. So the participants may not be aware of the voice morphing technology at all. So if you make them aware that, look, this kind of morphing technology are there are these kind of scams running, So if you make them aware, then maybe they might do better. They might do better on that. So I was thinking about, like, when I was talking about those kind of trainings.
Okay. Thank you.
Thank you.
Hi, thank you for your talk. So, Hadi, University of Florida. So the question I have is, so when giving these audio samples, right? Did you take into consideration like whether the audio sample was from a child, a toddler, an older gentleman? Like, did you take that into consideration?
Sorry, like, do you mean, are you talking about the voice samples, or are you talking
Yes.
about? No, we didn't consider that.
So which ones did you use?
So we like the voice samples we used were from Morgan Freeman or Pro Winfrey.
Okay.
And two of them were like young adults from Mechanical Turk.
Okay, awesome. Thanks so much.
Thanks. We wanted like, the reason was that we wanted clear voices to the participants, right? So that was the reason.
So I've got one more quick question. I think this is, particularly the fact that it's not possible to differentiate, at least for your participants. It's a bit of a surprising result, and in particular, I know that there's some people who've taken a look at your paper and are more familiar with this voice morphing technology, and they claim that they have the ability to differentiate. So are they liars, or are they overestimating their ability, or do we need to do more work here to see? I guess more broadly, I'm curious, where do you see this going? Do you have sort of future work planned in this space?
Like they might, that's what, right? They are already aware of this voice morphing technology, so they know that they can think in that way. Not many people can think in that pattern, so definitely they are pretty good at, they might be pretty good at it. If you study those samples, then maybe we can see some differences. I don't know, but especially in our case, when people didn't know about the morph voicing technology, we didn't see any differences.
Nice.
That's
Yeah.
where the problem lies, right? Many of the users don't know about it. That's what we're trying to make it aware of.
I mean, it would have been more entertaining if you called them liars, but I guess that's a good answer too.
Yeah, I can't.
All right, great talk. Let's thank our speaker.